So this is your trigonometry practice exam number 1, based on chapter 1. And I'm going to be going through your actual practice test. Now, you may have different numbers than what I have. In fact, you most likely will have different numbers than what I have on your practice test. And this is a really good analog for the real test. I'm going to show you what I'm looking at. I'm looking at question 1 here, and you can see that I have, I want to answer this first question. You can see this is a 30, 60, 90 triangle, and it's a right triangle. So the best description for this is going to be, I've never seen it called a 30, 60 right triangle. It's usually 30, 60, 90 right triangle, but that's definitely going to be the best description for that. I want to switch back. And I want to draw here. We have a 7 here. We have 30 degrees here, 60 degrees here. This is problem number 1. And I want us to go back to a generic 30, 60, 90 right triangle. And the side opposite the 30 is the 1. Opposite the 60 degrees, that's going to be root 3. And the hypotenuse in this case is going to be 2. Here's my right angle. And I want to also do this. We can expand this into, this is 1x. X, and x root 3. So x in this case, that's the one opposite the 30. In this case is the 7. So the hypotenuse in this case is going to be 2 times 7. Or 14, like I have here. And this side here is going to be 7 times root 3. And they want a decimal approximation of that as well. So 7 times the square root of 3, 12.12. So this is about 12.12. And they do not say where to round it off. That's okay. So that's problem number 1. Problem 2 is here. Let me adjust the camera. Problem 2 is we have a triangle. Over there, and they're labeling this angle A, angle B, angle C. And the side opposite is going to be the lowercase. So this side is going to be lowercase a, lowercase b, and lowercase c. And they tell us that C is 73, B is 55, and A is 48. Now, if we did the Pythagorean theorem on this, I'm quite sure that this would not be a real triangle. We're just trying to get this idea down. And they want us to find all 6 trig functions of angle B. So the sine of angle B, here's angle B. Sine is going to be the opposite, that's 55, over the hypotenuse, which is 73. The cosine of angle B, here's angle B, is the adjacent, that's 48, over the hypotenuse, which is 73. The tangent of angle B is going to be the opposite, 55, over the adjacent, which is 48. Now the cotangent of angle B is just the reciprocal of tangent of B. The secant of angle B is the reciprocal of cosine. And the cosecant of angle B is going to be the reciprocal of sine, 73 over 55. Looks like a lot of work, but it really isn't so much. Just the 6 trig functions. Let's move on to problem 3. Here we have another triangle. You give us that the hypotenuse is 11. The angle here is 34 degrees. And we are missing this side here. They want us to solve for x. Now, before we do any of this, I want to make it clear that you need to be in degree mode. Now, if you have a regular scientific calculator, it'll have a D or a DEG at the top. If it has R or RAD, you're in the wrong mode right now. You'll have to change that. So mine's in degree mode. And I need the trigonometric function that is going to have, relative to this angle, adjacent and hypotenuse involved. That's going to be cosine. The cosine of an angle is the adjacent, that's the unknown x here, over the hypotenuse, which in this case is 11. I'm now going to multiply through by the LCD, which is 11 in this case. And that's I'm gonna go this way. That's gonna give me that x is equal to 11 times the cosine of 34 degrees. This is why it's important that I'm in degree mode. So I'm gonna go 11 times the cosine of 34 degrees. So it looks like we're getting about 9.1194. And we don't have a unit for this one, so we can't say feet or meters or whatever it is that we're measuring. Next up. Oh, you know what, we can just go right to there, that's fine. Number 4. We have a triangle here. You see this is 39 degrees. This is 14. This is x, our unknown, what we're looking for. In this case, relative to this angle, I need the trig function that's going to relate the opposite over the hypotenuse. That's going to be sine. And I'm going to do what I did for the previous problem. And if I'm going too fast, you can always pause it, right? Multiply both sides by 14, or cross multiply if you want. This means that x is going to be 14 times the sine of 39 degrees. Now, I want you guys paranoid, and I mean that every time you make sure that you're in degree mode or radian mode, depending on the problem, just to make sure. So here we go. 14 times the sine of 39 degrees. And once again, you most likely will have different numbers than what I have. Moving on to number 5. And here's our triangle. And they want to know what that angle is. Well, I need the trigonometric function that has to do with the adjacent side and the hypotenuse. Once again, that's going to be cosine. It's the adjacent over the hypotenuse. Here, I'm going to have to use the inverse cosine. Actually, it's exactly to And I want to make it clear that is not an exponent. That doesn't mean to the negative first power. This is the inverse cosine function. So this is not 1 over cosine. It doesn't mean that. And you can see I have the inverse cosine in my calculator. Up just a little bit more. You can see it's above my cosine button. So I have to hit the blue button first in mine. Inverse cosine of 10 divided by 13. So the angle is about a little over 39 degrees. All right, now you should be verifying all of my numbers in your calculator. Just make sure that you're getting the same thing. It's like the more practice you do with the calculator, the more relaxed you'll be with it during the test is the hope. All right, let's move on to number 6. So number 6, it's going to be a triangle. This angle A, angle B, angle C, inside A, B, and C. And they tell us that A is 5, C is 6. They want us to find the missing side B as well as the 2 angles here. Let's start with the missing side B. I'm going to use the Pythagorean theorem for that. So 5 squared plus B squared equals 6 squared. Now remember, the hypotenuse is always the one that's by itself on one side of the equation. This means that B, and we're going to make it positive for now. It should be plus or minus. It's going to be root 11, which we could approximate. Square root 11. It's about 3.3166. Now to find angle A, I'm going to do this. Angle A, side A here is 5, and the hypotenuse is 6. So that's sine of angle A is 5 over 6, which means A is inverse sine of 5 over 6. So here we go. Inverse sine, sometimes called arc sine, of 5 divided by 6, 56.4427. And actually, angle B is what's called complement of A, so I can actually just do 90 minus that number. So 90 minus 56.4427. So angle B is 90 degrees minus 56.4427. About 33.5573 degrees. Here are the 3 answers that they asked for. All right. Number 7. They want an angle between 0 degrees and 360 degrees that is coterminal with the angle 1,298 degrees. So I'm going to go 1,298 minus 360 degrees. Now, to be clear, I'm just going to keep subtracting 360 until I get something between 0 and 360. So let's see what we got. So 1298 minus 360. Not enough. So minus another 360. Minus 360. Still not enough. Minus another 360. Now we're talking. 218 degrees. And the other side of that is asking the same question, except coterminal with negative 845 degrees. Now, because it's negative, I'm going to be adding 360 to it. Until I get something positive. So negative 845 plus 360. Okay, so I'm going to add another 360. Plus 360. Not quite there. One more 360. There we go. 235 degrees. Yep. Moving on to problem 9. So they want us to find the sine, all 6 of trig functions of the angle 0. So let's start here. Sine of 0 degrees, one presumes. Actually, it doesn't matter. 0 degrees, 0 radians, it's the same. I put that in the calculator and I get 0. Also, you could use the unit circle to determine these as well. Remember, sine is y and cosine is x. So let me show you. Sine of 0 is 0. Cosine of 0 is 1. And one of the reasons for that if I'm on the unit circle, I'm on this point right here, and this point actually is 1, 0. And remember, it's cosine, sine. The tangent of 0 degrees is sine of 0 degrees over the cosine of 0 degrees. 0 over 1, which is 0. We can see tangent of 0 is also 0. Now, cotangent of 0 degrees is the reciprocal of tangent. So if I flip that, I'm going to get 1 divided by 0. This is undefined. You can't ever divide by 0. In my open math, you'll put does not exist, DNE. Secant of 0 degrees is the reciprocal of cosine, and the reciprocal of 1 is 1. However, the cosecant of 0 degrees is the reciprocal of sine, and the reciprocal of 0 is again undefined. Picture cosine, or DNE, This is the same as 1 divided by the sine of 0 degrees. Make sure I'm still in frame there. I am. And sine of 0 is 0. So again, we have that same problem. We can't divide by 0. All right. Number 10. You say if the sine of theta is 3 over 6, and theta is in quadrant 2, they want us to find the rest of the trig functions. I'm going to reduce this real quick. And I'm actually going to set up a triangle. Here's my theta. The opposite is a 1. The hypotenuse is a 2. I'm going to call this x. And I need to find that third side. I'm going to use the Pythagorean theorem to do it. Here's my hypotenuse and my 2 legs. So this is going to be 1 squared plus x squared equals 2 squared. 1 plus x squared equals 4. Subtract the 1. You get x squared equals 3. This means that x is plus or minus root 3. Now, in quadrant 2, x is negative. So in actuality, this is going to be negative root 3 is what x is. Just real quick. So this is a negative root 3. This is a height of 1. And this is hypotenuse of 2. So kind of flip that one around a little. So the cosine of theta, and here's our theta. And then here's our reference angle is in there. And we're going to use our reference angle here. So this is going to be, the cosine is the adjacent, that's negative root 3 over the hypotenuse, which is 2. The tangent of theta is the opposite over the adjacent. So it's going to be a 1 over negative root 3. And if we rationalize that denominator, we're going to get root 3 over 3. As I tell my classes, I always used to have to do that. They're a little more loose on it now. Next up is the cotangent of theta. I could continue to use the triangle, but I'm going to go ahead and take the reciprocal here. This is just negative root 3 over 1, or just negative root 3. Secant of theta is the reciprocal of cosine. So it's going to be negative 2 over root 3. And if we rationalize that, that'll be negative 2 root 3 over 3. Again, old school, we always rationalized our denominators. Again, they're getting a little more loose on that nowadays. And cosecant of theta is the reciprocal of sine. So the reciprocal of sine is going to be 2 over 1, or just 2. All right, we're getting there. Number 11 says, if cosine of theta is negative 2 over 7, and the tangent of theta is less than 0. Tangent is negative or less than 0 in quadrants 2 and 4. It's positive in quadrants 1 and 3. Cosine is negative in quadrants 2 and 3. That's where x is negative. So what quadrant are we in? Looks like we are in quadrant 2. So it shares both. All right, now that we have that cleared up, go back here. Hypotenuse here is 7. Hypotenuse is always positive, which makes this the negative 2. Because theta, or the reference angle, always needs to be the, for cosine, is going to be the adjacent the hypotenuse. Now I'm going to need to do some Pythagorean theorem to get the rest of that triangle. So I'll call this y. Please note y will be positive in quadrant 2. Now y is going to be plus or minus, but we need to think about this. In quadrant 2, y is positive. So this is going to be the positive square root. Do it out of habit now. Square root of 45, which we can simplify into 3 root 5. And now they want to know all 6 trig functions, or the remaining 5, I should say. So we'll start with sine of theta. Theta is here. Sine of theta is going to be the opposite. So this is the 3 root 5 over 7. Cosine I have right there. Tangent of theta is going to be the opposite 3 root 5 over the adjacent, which is negative 2. Yeah. Cotangent of theta is going to be the reciprocal of tangent. That's negative 2 over 3 root 5. We could simplify that to negative 2 root 5 over 15. Either answer should work. Secant of theta is going to be the reciprocal of cosine. That's going to be negative 7 over 2. And cosecant of theta is the reciprocal of sine, positive 7 over 3 root 5. And if we wanted to simplify or rationalize that, it would be 7 root 5 over 15. All right, next up, number 12. So I can use the back of this one. I can. So we are there. Number 12. We're looking for reference angles. There's 3 parts to this one. Part 1, we want to find the reference angle of 217 degrees. 217 degrees is in quadrant 3. So this angle here is 217 degrees. Our reference angle that we're interested in is right here. So this is going to be my theta sub r, my reference angle. So what I'm going to do for this 217 is I'm going to subtract 180 degrees. So 217 minus 180 degrees, and that's going to leave me the green. So theta sub r is going to be 217 degrees minus 180 degrees, which is going to be 37 degrees. Remember, your reference angle is always the angle that gets you to the x-axis quickest. Always the x-axis. For 2, find the reference angle of 318 degrees. 318 degrees is in quadrant 4. So now we're down here. Once again, we are looking for this angle here. And the way we're going to get that reference angle, I'm going to go 360 degrees minus the 318. And that should give me that difference right there. 360 degrees minus 318. 42 degrees is the reference angle for 318 degrees. One more. Okay. Third angle is negative 154 degrees. Negative 154 degrees. I could convert that to be between 0 and 2 pi, but a little trick here. This from here to here going backwards, negative, is negative 90 degrees. All the way to here is a negative 180 degrees. So do you see that this angle is in quadrant 3? I'm looking for this angle. I'm just going to go 180 degrees minus 154 degrees. 180 minus 154. 26 degrees. We're doing fine. All right, reference angles. Now, if it helps you to convert this into like add 360 to it so you get a better feel and you want to do everything the positive, that's fine too. There's nothing wrong with that. You'll still end up with a 26-degree reference angle. Nope. Number 13. Is 2 parts. We are looking for the exact value of sine 570 degrees. So we're going to have to do a few things here. I got to find its coterminal between 0 and 360, and I need to find its reference angle. All right, so I'm going to take 570, subtract 360, gets me to 210. So I got that by going 570 degrees minus 360 degrees. 210 is in quadrant 3. right? 0 to 90 is there. 90 to 180 is there. 180 to 270 is here, so it's here. I want the reference angle, because then I'll get to use one of my special triangles. Now you can also use the unit circle, but both will get you the same answers. So let's see what that is. That's going to be 210 minus 180. So 210 minus 180. That's a 30-degree reference angle. So let me draw out the triangle that we're looking at here. So here's my 30-degree angle. And again, I got that theta sub r is 210 degrees minus 180 degrees. So that gives me a 30, 60, 90 triangle, actually. Side opposite is 1. Now I'm in quadrant 3, so that's actually a -1. That makes this a 2. Hypotenuse is always positive. And this is also going to be negative. This is going to be negative √3. This is my special right triangle, 30, 60, 90 triangle. But be real careful with the signs here. So now the sine of this angle, the sine is going to be the opposite here. So that's going to be, my answer is going to be a -1/2. Part 2 is cosine of the same angle. Well, that's going to be this triangle again, but now it's going to be the adjacent, -√3/2. Yeah, once you get that to that triangle and you get the signs correct, just be real careful with that. All right, moving on to number 14. I'm going to get a new page. This is going to be cosecant, which is 1/sine of -1350 degrees. All right. So again, we're going to have to get the coterminal between 0 and 360 angle, and then we need to find the reference angle, if that applies, which this one it may not. All right, so I'm going to go -1350. Let's see how many 360s we got to go. It's going to be quite a few. -1350 plus 360 plus 360 plus 360 plus 360. There we go. How many did I add? Quite a few. So this becomes, yeah, exactly equal to 90 degrees, positive 90 degrees. I should say this is an equivalent of 90 degrees. All right, so we know that sine of 90 degrees is 1. So if you look at the unit circle, in fact, I can at 90 degrees. So here's that point. That is the point 0, 1. Remember, sine is y, and so the y coordinate there is 1. So cosecant, -1350 degrees is the reciprocal of that, which is just 1. 1 is 1/1. So when you flip that, you still get 1/1. Number 15 are two problems. They are somewhat related. We just have to dig out the triangle. 15. So part 1, we're looking for the tangent of 1830 degrees. And I'm going to do 1830 minus 360 minus 360 minus 360 minus 360 minus 360. Hey, 30 degrees. So this becomes the same as the tangent of 30 degrees. And I can draw my 30, 60, 90 triangle very nicely. Notice we're in quadrant 1, so we don't have to worry about the signs. Everything's positive. All right, so the tangent of 30 is going to be the opposite over the adjacent. 1 over root 3, or if we rationalize that, that's root 3 over 3. Either answer should work. In the second part, they want the cotangent of the same angle. 1830 degrees is the reciprocal of that. Root 3 over 1 or just root 3? All right, number 16, let's adjust this. All right. Number 16. So we have that the tangent of theta is negative 7 over 5. And the sine of theta is negative, less than 0. All right, so sine and tangent are both negative. So that happens. Sine is negative when y is negative. So sine is negative in quadrant 3 and 4. Tangent is negative in quadrants 2 and 4. So it looks like quadrant 4 is where we are. No problem. Let's draw this out. And we're in quadrant 4. And we'll just draw a nice little triangle there. We know that the tangent is the opposite. So that's going to be negative 7 over the adjacent, which is going to be a positive 5, because tangent is y over x. Y is negative in quadrant 4 and positive in quadrant 1, in quadrant 4. So we are missing the hypotenuse. We'll call that r. I'm going to go r squared is equal to this 5 squared plus negative 7 squared. Plus 49, 74. So this is root 74. And this is our theta to there. And of course, we're going to be using that angle there. And because I put the negative on the side there, that's going to help us with the signs. And they want to know the remaining trig functions. Cool. So make sure we have enough space. Well, it's going to have to be. All right, so sine of theta is going to be the opposite over the hypotenuse, negative 7 over root 74. Once again, you could rationalize that. And I want to be clear, well, I've said it over and over again. Sine is negative in quadrant 4. Cosine of theta is going to be the adjacent, that's 5 over root 74. Tangent we already have. Cotangent of theta is going to be the reciprocal of that, negative 5 over 7. Secant of theta is going to be the reciprocal of that. That is a positive root 74 over 5. Notice cosine is positive in quadrant 4, which it should be. The cosecant of theta is going to be the reciprocal of this here. So negative root 74 over 7. Not too bad once you get the swing of it. All right. Number 17, I need a little more space. This is the last problem for the practice test. (17). They give us an angle 240 degrees. And they want us, without a calculator, to find the sine, cosine, and tangent of 240 degrees. Let's talk about what that looks like first. (240 degrees is in quadrant 3. Down here. 240 degrees. However, its reference angle it looks like I'm going to go 240 degrees minus 180 degrees to get the reference angle, which I believe is 60. 240 minus 180. 60 degrees. So our reference angle is 60 degrees. Keeping in mind that we're in quadrant 3. Remember, both x and y are negative in quadrant 3. Meaning sine and cosine are both negative in quadrant 3. However, tangent is positive in quadrant 3. So let's draw our triangle. I'll draw it like the picture we have here to be consistent. (60-degree angle. That makes that a 30-degree angle. That makes that a -1. That makes this a negative root 3. Makes that a 2. Again, going back to our special right triangles, x is negative, y is also negative because, once again, we're in quadrant 3. So now they want us to find sine, cosine, and tangent. Sine of 240 degrees is going to be the opposite, negative root 3 over the hypotenuse, over 2. Cosine of 240 degrees, cosine, is going to be the adjacent, -1 over the hypotenuse, which is 2. And the tangent of 240 degrees is going to be the opposite over the adjacent. So negative root 3 over -1 reduces to just positive root 3. And we know that tangent is positive in quadrant 3 for exactly this reason. The two negatives reduce. Good luck on your test. I hope that this was helpful. Take care.